Hello and welcome. This is a video on the rules of exponents. Well, it's called the rules of exponents, but really what I'm going to be teaching you is a bunch of examples of applying the rules of exponents to actual math problems. Okay? So remember, when you have an exponential, something like 8 to the second power, we say 8 to the 2 or 8 to the second power. The 8 would be called the base. Okay, so 8 would be the base. And then 2 would be the exponent. Okay? And remember that what an exponent means is you multiply the number times itself that many times. So for example, 8 to the second power, or 8 to the 2, means you do 8 times 8. And how many times do you do it? Well, you do it exactly 2 times, which is the same as the exponent. Okay? So whatever your exponent is, that's how many times you multiply the number by itself. And of course, it doesn't have to be a number. It can also be a variable. So for example, instead of 8 to the 2, I might have x to the 2, or x squared. X squared is the same as x to the second power. Okay, so instead of 8 times 8, I'm actually going to have x times x. But it's still going to be just 2 times. Okay? Now if I increase my exponent, so for example, if I make my exponent be 4, then whatever that exponent, that's how many times I multiply x times itself. So now instead of being 2 times, we need to multiply x by itself 4 times. Okay, so we're going to actually have x times x times x times x. A total of 4 x's being multiplied together, which is exactly the same as this number here, the exponent. Okay, so all it means, an exponential just means you multiply the base times itself a total of the exponent number of times. Okay, but that's not really a rule of exponents. That's just a review of exponents. So now I wanted to do some examples of which are probably mostly review, but are important before we actually jump into the rules of exponents, even though the title of this section is Rules of Exponents. Okay, so what I wanted to do first is an example. Okay, and the instructions are evaluate. Now when they say evaluate, that's the same as saying simplify. Okay, so basically they want you to just simplify the expression. For problem number 1, we have negative 8 to the second power. Now the reason I'm doing this one is these always confuse people, and I wanted to just go over it. Even if it's review for a lot of people, other people will need this review. So the thing about negative 8 to the second power is because there's not parentheses around the negative 8, it actually means that the 2 doesn't apply to the negative. Okay, so what this means is it actually means negative of 8 times 8. Okay, it does not mean negative 8 times negative 8. So it means negative 8 times 8. So there's not going to be a second minus to cancel out with. And 8 times 8 is 64. So we actually get negative 64. And that's our answer. Okay? Negative 64 is our answer. Okay, and then I wanted to do another example that's very similar, and you would think would have the same answer, but it doesn't. Okay, just to make sure that you don't get confused by these. So example number 2 is going to be parentheses, negative 8, parentheses to the second power. In other words, the quantity negative 8, quantity squared. Okay, so you would think that this would just give you negative 64, just like the last problem. However, there's an important difference between these two problems. On the first one, there was no parentheses around the negative, so that meant that the square actually only applied to the 8. It didn't apply to the minus. Whereas on this second problem, we have parentheses around the negative as well as the number. So this is actually going to mean the entire parentheses times itself. So this is going to mean negative 8 times negative 8. So because there's two minuses this time, on this one, the minuses are going to cancel out. And they're going to give us 8 times 8 is positive 64. So this one's actually going to be positive 64. And I like to always start off with those two types of examples at least, because they throw people off all the time, because it's just a little bit of math notation that can be kind of confusing. Okay, but hopefully we're good with that. All right, and then let's take a look at our next example. Example number 3. So this one is actually negative 10, parentheses around it, raised to the first power. Now, any number to the first power is just a number. Okay, so this literally just means negative 10, and that's our answer. Okay, and that brings us to our first rule of exponents. Okay, which is basically just saying that if you have an exponent x, let me write the rules of exponents over here. Rules of exponents. I'm just going to write them down as we use them in examples, because there are too many of them to write all at once. So the one that we're using here for our rules of exponents, the first one we're using here is, I just said that if you have a number and you raise it to the first power, or a variable and you raise it to the first power, that's just the variable or the number. So x to the 1 is just going to equal x. Okay, so here, negative 10, parentheses to the 1 is just negative 10. Okay, so with that information, I think you should be good for your first type of homework problems. Again, they're probably review for most people. Okay, now for our next example, we're going to have the same instructions, but now we're going to start dealing with variables. Okay, the first 3 examples just had numbers, which are generally easier to evaluate. With variables, it's more abstract, and with variables, many calculators won't be able to do it for you. So these you actually have to understand the math. So for example number 4, we're going to be doing x to the 6th power times x to the 3rd power. Okay? X to the 6th power times x to the 3rd power. All right, so before we do this, we need another rule of exponents. So let's go back to our rules of exponents. So this is going to be rule number 2. Now this one says that if you have x to the a times x to the b, in other words, you're multiplying two exponentials that have the same base. They have to have the same base for this to work. Then what you do is you add the exponents. So that's going to equal x to the a plus b. Okay, so multiplying exponentials with the same base means you add the exponents. And we can see on this example number 4 that these are the same base. So to multiply exponentials with the same base, you just add the exponents. So this is actually going to give us x to the 6 plus 3, okay, x to the 6 plus 3, which is x to the 9, okay, because 6 plus 3 is 9. And that's the whole problem. Now that's not something that you can do on most calculators, but it's not that difficult if you just use the rule of exponents. You're really just adding, which is not so bad. Okay, so x to the 9 is the example number 4 answer. Of course, these can get more difficult. Mostly when you start putting numbers in there, it can throw people off. Okay, so for example number 3, we're going to look at a little bit harder one. Not example number 3. Excuse me. Example number 5. That was number 4. Next one is number 5. Oh well. Just had a brain fart, I guess. Okay, so number 5 is going to be parentheses 6x to the 5th times parentheses 4x. Okay, parentheses 6x to the 5th times parentheses 4x. Okay, so with this one, the main trick is to realize that 6 and 4 are numbers, they're constants, whereas x to the 5th and x, those are variables. So you need to multiply the constants and the variables separately. Okay, so let me write that down. Multiply constants and variables separately. And when I say separately, I mean you can't combine them with one another. You can't combine a constant with a variable, or vice versa. So like here, it's sort of like terms. You're going to be doing 6 times 4. 6 times 4 is 24. Okay, that's the constants. And then for the variables, we have x to the 5th times x. Now we need to go back to our first rule of exponents here. So when you just have the variable x, what does that mean in terms of an exponent? Well, going back to our first rule, we said that x to the first power equals x. Okay, so we can always write a 1 in there so that we can use our second rule. So that's actually the trick here. So instead of just writing 4x, we're actually going to write 4x to the 1. Okay, so I'm going to write in a little 1 there. And then what I do is combining the variables, because they're exponentials with the same base, and we're multiplying, we add the exponents. So we're actually going to get x to the 5 plus 1, okay, which is x to the 6. So we get 24 x to the 6. Pretty cool, huh? That's the whole problem. Now, you got to resist the urge to combine the 24 with the 6. You're not allowed to do that. Remember, 6 is the exponent of a variable, and 24 is a constant out front. Those are two separate things. You cannot combine those. So you just leave your answer as 24x to the 6. Okay, and that's the whole problem. Now, so far we've just dealt with expressions that have one variable. So in the next example, I wanted to do a problem where we had more than one variable, just to change things up. So this is going to be example number 6. So for example number 6, we're going to have two variables, m and n. So we're going to have parentheses, m to the 13, n to the 3, okay, times parentheses, m to the 12, n. Okay, so we have two sets of parentheses. In the first set of parentheses, we have m to the 13 times n to the 3, which is the same as n cubed. And then in the second set of parentheses, we have m to the 12 times n. And remember, if it's just n like that, if it's just a single letter, a single variable, that's the same as n to the 1. So I'm going to go ahead and write in a 1 there. All right, so when you have two variables or even three variables, you can only combine variables that have exactly the same base. Okay? So let me write that down. Only combine variables Well, I shouldn't say variables. I should say exponentials. So exponentials are these things where we have exponents. So only combine exponentials or powers would be an even better way to say it, that have the same base. With the same base. Okay, so what does that mean here? Well, just like in the last problem, it's sort of like terms, but here our like terms are going to be m and n. So we've got m to the 13 times m to the 12, and then we have n to the 3 times n to the 1. But once again, they have the same base, so we're just going to add the exponents. So dealing with the m's, we have m to the 13 plus 12. Okay, and then for n, we have n to the 3 plus 1. Okay, m to the 13 plus 12 and n to the 3 plus 1. Now we cannot combine those with each other because they have different variables. So different variables cannot actually interact. They just kind of stay separate. But we can go ahead and add. So 13 plus 12 is actually 25. So we get m to the 25. And then 3 plus 1 is 4, so we get n to the 4. Okay, so we have m to the 25 times n to the 4. All right, that's as simplified as it gets because you're not allowed to combine variables with one another. All right. So I think you should be good for your first few homework problems now. I just wanted to do maybe one more that uses all of these together. Okay, so example number 7. Example number 7. This one is parentheses 4z to the 11 times parentheses negative 5z to the 8 times parentheses z to the 4th. Okay, so parentheses 4z to the 11th times parentheses negative 5z to the 8th power times parentheses z to the 4th power. Now this one only has one variable, so that's not so bad. But it does have a lot of stuff going on. But once again, you want to focus on the constants out front separately from the variables. So here, combining the constants, we're going to have 4 times negative 5. And then for the z to the 4th, you need to realize that if they don't write the constant, it's automatically 1. So that's really just 1 times z to the 4th. Okay, so we're really just going to be doing 4 times negative 5 times 1, but any number times 1 is the number. So really all we're doing is 4 times negative 5, which is negative 20. Okay, and then the other thing that we need to simplify here is the variable z. So we have a z to the 11th, a z to the 8th, and a z to the 4th. So these are multiplying exponentials with the same base, so we're going to be adding the exponents. And even though there's 3 of them, you still just add the exponents. So you add all 3 of them. And that's why I'm doing this example. So you can see that that's actually, you can do it all at once. So it's going to be z to the 11 plus 8 plus 4. Okay? Z to the 11 plus 8 plus 4. So 11 plus 8 is 19, right? And then 19 plus 4 is 23. So we're actually going to have z to the 23, but don't forget we still have a negative 20 out front. Okay, so our answer is going to be negative 20 z to the 23. Negative 20 z to the 23. All right, And that is the whole problem. Okay, cool. So, we need to learn a new rule of exponents, but let me give you a motivation for that first. So for example number 8 here, we've got a power. So we have y to the 8th, and then we're raising that power to the second power. So we have parentheses around y to the 8th, and then we have the parentheses raised to the second power, or squared. So we would say the quantity y to the 8th quantity squared. So here you got to be careful. You do not add the exponents. You're not adding exponents because we're not multiplying two exponentials with the same base. We're doing something different here. We're raising one power to another power. So we're going to need a new rule here. So going back to our rules, oops. Well, they're up here somewhere. Okay, here we go. Going back to our rules, let's learn another rule. So number 3 says that if you're raising a power to another power, so if you have x to the a, and then you raise it to the b, in other words, parentheses x to the a, parentheses to the b, you actually multiply the exponents. You don't add them. Okay, so this is actually going to be x to the a times b. Or some people would just say x to the ab, because ab means a times b. Alright, so it's so common for people to get these confused that I'm going to point out that you do not want to get these confused. Okay, so don't get these confused. Don't get these confused. It's so easy to do, and people do it all the time, even in more advanced courses, so that's why I'm bringing it up. So basically, if you have one exponential times another exponential, or a power times a power, and they have the same base, you add the bases. Whereas if you're raising a power to another power, in other words, you have parentheses around an exponential, and you're raising the parentheses to another power, you multiply the exponents. Very important that you keep those straight in your head. Okay, cool. So if you keep them straight in your head, these problems are actually really easy though. So here we have a power raised to a power. So that means we multiply the exponents. So this is just going to be y to the 8 times 2. And 8 times 2 is 16. So our answer is y to the 16. So that problem is actually just one step. So as long as you use the correct rule, it should be a very easy problem. Okay? So, moving onward. Problem number 9. Okay, so for problem number 9, we're going to have a bit of a different problem. So for this one, we have parentheses. Okay, oops. Parentheses, -7, a squared, b to the 5th, c. And then we're raising these parentheses to the second power. Now this is a lot harder problem, but it's actually not that bad. The only thing to keep in mind here is that if you have multiple factors and you have parentheses around them, when you're raising them to a power, you're actually allowed to distribute the exponent. Now, this does not work if you have multiple terms, but as long as you just have multiple factors and you're raising them all to a power, you can distribute that power. So I'm going to distribute this 2 to every single exponent. Okay, just make sure that you distribute it to every exponent. Okay. Now this one comes from yet another rule of exponents that we haven't learned yet. The idea that you can distribute it. So let me go back up to our rules of exponents. So we're going to call this rule number 4. So rule number 4 says if you have x times y and you raise it to the a power. So if you have two different variables and then you're raising them both inside parentheses to a power, you can actually just distribute the exponent. So that's going to give you x to the a times y to the a. Okay, x to the a times y to the a. So literally all that's saying is that you distribute. The only thing to be careful about is if you have something that has more than one term, like if you have two things multiplied, if you have two things added together or subtracted together, you can't distribute. But here, because the things are multiplied together, you can distribute the exponent. Okay, so that's why we were allowed to do what we did down here using that rule. It's just sort of like I used the rule over and over again because I didn't just distribute to two variables, I distributed to every single thing inside the parentheses. Okay, so what's this going to look like? Well, we're going to have a negative 7 squared. We're going to have a squared squared. We're going to have a b to the 5th squared. And then we're going to have c squared. Now notice for the a squared, the negative 7 squared, and the b to the 5th squared, I put parentheses around it. But for the c squared, I didn't bother to put parentheses around it. Now why did I do that? Well, for negative 7, it's a negative number, so it has to have parentheses around it to do it properly. For the a squared and the b to the 5th, it needs to be clear that we're raising it to a power. So that's why I put parentheses there. But for the c squared, we just had a single variable, so we already know that c squared is c squared. So there's no need to write parentheses for this one. Okay? And now we can actually simplify each of these factors separately. So starting with the negative 7 squared, remember that that means negative 7 times negative 7. Okay? And then for the a squared squared, you're raising an exponential to a power, so you multiply the exponents. So that's going to be a to the 2 times 2. And then for the b to the 5th squared, we're multiplying the exponents. So that's going to be b to the 5 times 2. And then finally, we have c squared. But c squared is already simplified, so we don't have to worry about that one. Okay? And then negative 7 times negative 7, well, the minuses cancel. And 7 times 7 is 49. So we have a 49. And then a to the 2 times 2 is a to the 4. So we have 49 a to the 4. And then we have b to the 5 times 2 is b to the 10. And then times c to the 2, or c squared. And I know it looks like you'd be able to simplify this more because it's so complicated, but you can't actually get this any more simplified. So this is actually going to be our answer. I'm going to box it. 49 a to the 4th, b to the 10th, c to the 2. Now why can't I simplify this more? Well, let's look at it. The 49 is a constant, and there's no other constants to combine it with. A to the 4th is already simplified, it's a power. B to the 10th is also simplified, and c squared is also simplified. So the thing is, there's really nothing that can be combined because these are all separate variables. And when they're different variables, you can't combine them with one another. So you just leave them that way. Okay, so that was our first relatively tough problem because it had more steps. All right, so now I'm going to be doing a lot of examples. So for problem number 10, I wanted to dive in to yet another type of problem. And for this one, we're actually going to need not just one new rule, but two new rules. Okay, so for number 10, we have a fraction. And for our fraction, we have r over s. And then we have r over s, parentheses around it, raised to the 11th power. Okay, so we have the quantity r over s, quantity to the 11th. Now, what do we do with the exponent? That's the big question. Well, it turns out, just like when you have things multiplied together, if you have things divided and you're raising them all to the same power, you can distribute the exponent. Okay, so once again, we're going to be distributing the 11 to the top and the bottom. So, and you're allowed to do that as long as your numerator and your denominator don't have more than one term. And here, the top has one term and the bottom has one term. Okay, so that's actually going to get us r to the 11th on the top and s to the 11th on the bottom. S to the 11th on the bottom. I'm trying to work on my s's because people say they look like 5s, so I'm trying to work on that. But sometimes I just write the old s, which looks like a 5. Teacher problems. Okay, so what did I do there? I just distributed. Now technically this is a new rule, so let me go back up to our rules, for those of you who like rules. Okay, so rules of exponents. I'm going to scroll down a bit. This is rule number 5. So for this one, if you have a fraction, x over y, and you raise the fraction to a power, a, then it says that you're allowed to distribute the power to the numerator and the denominator. Okay, so we can go ahead and just distribute the a to the top and the bottom. So that gives us x to the a on the top and y to the a on the bottom. Okay, that is distributing. And I think I misspoke earlier. I said that we were going to use two rules on this problem. Well, I'm kind of tired. Didn't have as much coffee as usual today. So the thing is here, we can't actually use two rules. We can only use the one rule that I just wrote. Now, the reason we can't simplify this anymore is these exponentials have different bases. We have an r as the base on the top and an s as the base on the bottom. So I was incorrect. You can't simplify this anymore. So this problem is actually just one step. You distribute to the top and the bottom, and then you're done. So that one should be pretty easy if you just understand how to distribute. Okay. Now, I wanted to use that same rule, but I'm going to combine it now with some of the other rules we've learned in a harder problem. So for number 11, example number 11, we're going to take a look at a complicated looking fraction. So what we have here is big parentheses, and then in the numerator of our fraction, we have 6x to the 5th z cubed, and then in the denominator of our fraction, we have y squared. Okay, so parentheses around a big fraction, numerator is 6x to the 5th z cubed, and then the denominator of the fraction is y squared. And then these parentheses go around the whole fraction, and then we're raising the fraction to the third power. Okay, so it turns out you can still just distribute here. Now, the reason you're allowed to do that is you can always distribute as long as there's only one term on the top and one term on the bottom. And in this case, there is only one term on the top and only one term on the bottom. Remember, terms mean things not multiplied together, but added together or subtracted. So because nothing is added or subtracted here, you can literally just distribute it. Okay, so distribute. So I'm going to distribute this exponent to every single power. So to the z to the third, to the x to the 5, to the 6, and to the y squared. Now, if you did have more than one term on the top, for example, if you had x plus y or x minus y on the top, you would not be allowed to just distribute the exponent, because if you have more than one term, that does not work. If you have, for example, if you have x plus y squared, then you would have to use FOIL. But here, because we only have one term on the top and one term on the bottom, we're allowed to just distribute. Okay, so in the numerator, we have 6 cubed, or 6 to the third power, and then we have x to the 5th to the third power. Notice I put parentheses around that one. And then I have parentheses z cubed cubed. In other words, z to the third power raised to the third power, all over y to the second power raised to the third power. Okay? And you're allowed to distribute on both the top and the bottom because we only have one term, and also because in the numerator we have things multiplied together. So that was actually using one of the earlier rules that we learned. Okay, so in the numerator we have things multiplied together, so we were able to distribute the exponent to each factor in the numerator. That's using rule number 4. Okay, and then in the denominator we're also allowed to distribute the exponent to each factor in the denominator using rule number 5. Okay, in other words, rule number 4 and rule number 5 basically say the same thing, which is if you have parentheses around something and it has multiple factors on the top and the bottom, you just distribute that exponent to every single factor, as long as nothing has more than one term. Okay, cool. So that's actually a nice technique for doing these. And then for 6 cubed, if you can't do that in your head, you can use a calculator, but it's not too bad. 6 times 6 is 36, and so then you're doing 6 times 36. So I believe that's 216, but sure, you can use a calculator or write it out vertically. Probably faster to just write it out vertically, so 6 times 6 is 36, and then to get 6 cubed, we have to multiply by 6 one more time. So 36 times 6, well, let's see, 6 times 6 is 36, carry the 3, 6 times 3 is 18, plus 3 is 21, so you get 216. Yeah, so I was correct. Okay, or you can use a calculator if you feel like being lazy about it, or you just want to check your work. Okay, so the 6 cubed is going to be 216. And then for all these other exponentials, recognize that we're raising a power to a power. So we're going to be multiplying all of these. So for x to the 5th to the 3rd, we're going to do x to the 5 times 3 is x to the 15. Same thing for z. Z to the 3 times 3 is z to the 9. Okay, and then on the bottom, y to the 2 times 3 is y to the 6. Okay, so in the numerator we have 216 x to the 15, z to the 9. And then in the denominator, we actually have y to the 6. Hey, what do you know? That's what they got on my math lab as well, so we did it right. So that one's a bit harder, a lot of stuff going on there. And believe it or not, we still have not learned all of the rules of exponents yet. It's kind of overwhelming how many of them there are, but it's not so much that they're hard, it's just that there's a lot of them. Okay, so we have a few more examples to do here. That was example number 11. Let's take a look at example number 12. So for example number 12, we're dividing, and we have x to the 13 divided by x. x to the 13 divided by x. Now this is interesting. Here we're going to need a new rule. But before we do it, let's use a rule we already know, which is in the denominator. Remember, if you just have the variable x, the exponent is actually 1. So right off the bat, I'm going to write x to the 1 in the denominator. Okay, now the question is, how do I simplify this? Well, like I said, we need a new rule. And it turns out that the new rule is, if you're dividing exponentials that have the same base, you subtract. And the order does matter. It's top to bottom, left to right. Okay, so let's go back up to our rules of exponents. Oops. This is going to be rule number 6 of our rules of exponents. So for rule number 6, if you have two exponentials with the same base and you're dividing, so for example, if you have x to the a over x to the b, then you subtract. Okay, so you subtract, and the order does matter when you're dividing and subtracting. So the dividing is top to bottom, which means that the subtracting has to be from left to right. Okay, so this is going to be x to the a minus b. Okay, and over here on the side, I'm going to write down what I just said. So remember, order matters. I don't need to write remember. I need to write order matters. And the order is exactly the way you think it would be, you know, given that we're learning in an English-speaking region. So the order is the same order you read, top to bottom, left to right. Top to bottom. That's numerator to denominator for the dividing. And then it's going to be left to right for the subtracting. And that you might think, well, why is he bothering to take up so much time talking about this? Well, it's just sometimes people get the order switched in their head, and that's going to definitely give you the wrong answer. The order does matter. It doesn't matter when you're multiplying or adding, but if you're dividing and subtracting, the order matters. And it's got to be top to bottom, left to right. Okay, so let's go back to our example. So for example number 12, we're dividing exponentials with the same base. So we subtract the exponents, top to bottom, left to right. Okay, so this is going to give us x to the 13 minus 1. X to the 13 minus 1. So that's top to bottom, left to right. And 13 minus 1 is 12. So we have x to the 12, and boom, that's the whole problem. Pretty cool, huh? Okay, so what we're going to be doing next is sort of combining all these rules together to try some more challenging problems. So let me kind of skip ahead in your homework here and try to do something a little more difficult. So number 13, example number 13, has a bit more stuff going on. So for this one we have 4 h to the 7 g to the 5 all over 24 h to the 7 g squared. Okay, so 4 h to the 7 g to the 5 all over 24 h to the 7 g squared. Alright, so for this one, it looks kind of scary because it's got so much going on. But if you focus on each part individually, it's not actually that bad. So what we're going to focus on first is the 4 over 24. And then we're going to focus on h, and then we're going to focus on g. So let's start with the 4 over 24. Just like when you're multiplying, you can only combine stuff that is the same in certain ways. So like here, the 4 and the 24 are the same because they're both constants. And then the h to the 7, those are sort of like terms, but here they're like factors. because they have the same variable. And then the last one would be the g to the fifth and the g squared. Those are also like factors because they have the same variable. So I circled those three different things that we're going to be focusing on. So starting with the 4 over 24, to simplify this fraction, we need to find a common factor of both 4 and 24. So remember that 4 times 6 is actually 24. So the biggest number that goes into both 4 and 24 is going to be 4. So what we're going to do is we're going to divide the top and the bottom by 4. Okay? So right now I'm just focusing on the red part, which is 4 over 24. On the top, 4 divided by 4 is 1. And then on the bottom, 24 divided by 4 is 6. Alright, so that took care of the constants. Now let's take care of the h to the 7th. Now here we're dividing exponentials with the same base, so we're going to subtract. And the order does matter, top to bottom, left to right. So it's going to be h to the 7 minus 7. And that's in your numerator. Okay, so that's going to be up here, h to the 7 minus 7. Okay, and then the last thing we're going to look at are the g's. Okay, so for g, once again we're dividing, so we subtract the exponents, and the order matters, top to bottom, left to right. So we're going to be doing g to the 5 minus 2. Okay, so we have g to the 5 minus 2. Okay, and of course now we can simplify this a little bit. So in particular, what we can do is, in the numerator we have h to the 0, because 7 minus 7 is 0, and 1 times any number is the number. So we have h to the 0, and then for g, 5 minus 2 is 3. So we have g cubed. And then don't forget we still have a 6 in the denominator. Now the real question is, what is this h to the 0? What does that mean? Well, some of you probably already remember from an earlier lecture where we talked about exponents a bit, that any number to the 0 is 1. But that's actually going to be another rule that I should write up here. Okay, so rules of exponents. This is going to be rule number 7. And I'm just doing it in this order because it was convenient for the lecture. Okay, so rule number 7 is any number to the 0 equals 1. So x to the 0 equals 1. And that's anything. Any number to the 0 is 1. Right, so that's actually one of the easier rules to remember. So this h to the 0, I can just cross it out, that's just 1. So we actually just have 1 times g cubed on the top, which is just g cubed. Okay, so we get g cubed on the top, and then 6 on the bottom. And that's going to be our answer. G cubed over 6. G cubed over 6. Okay, pretty cool, huh? And so that was one of the hardest problems on your homework. There's just a couple more that I wanted to look at here. I know I'm doing an awful lot of examples, but I like to make sure you see every case. So that was 13. Let's take a look at problem number 14. Okay, so for problem number 14, this one is very easy if you were just listening to what I said. Okay, so this one is negative 9x, parentheses around the whole thing. So parentheses negative 9x raised to the 0 power. Okay, well, what was this new rule that we just learned? The new rule said any number to the 0 is 1. Well, negative 9x is just going to be some number, so that number to the 0 is still 1. Okay, so this whole thing is just going to be 1. Now, it is important that you notice the reason this is 1 is because the parentheses go around the entire negative 9x. So that 0 basically just gets rid of everything there and makes it 1. Now, if there weren't parentheses around the entire expression, then the 0 would only make the x be 1. It wouldn't affect the negative 9. That's an important detail to know. Okay, and in fact, it's important enough, I think I'll do one more example of this particular type of problem. Okay, so for example number 15, we're going to have almost the same expression as what we just had, but a little difference. We have negative 9x to the 0. So what's the difference between number 14 and number 15? They almost look like the same thing. The only difference is with number 14, there's parentheses around the entire negative 9x, so the 0 makes that entire thing become 1. But for number 15, there's not parentheses around the entire negative 9x, so this one is actually going to give us a different answer. Now what's going to happen here is because there's no parentheses around the negative 9, the 0 only refers to the x. So this is actually, the 0 is only going to turn the x into a 1, but it's not going to affect the negative 9 because there's no parentheses. So the negative 9 is still going to be there. So this is actually going to give us negative 9 times 1, which is negative 9. So this one gave us a completely different answer. They're almost the same problem. The only difference is this one has parentheses and this one doesn't. But notice they got completely different answers, so that is important that you understand the difference between those two. Okay? All right, and that completes this lecture. Thank you for watching.